This is a virtual poster presentation for the International Cannabinoid Research Symposium 2021. The title of the poster is Transformation of Phytocannabinoids by Heat, Isomerization, Dehydration, and Derivatization of Cannabinoids Present in Cannabis Sativa Smoke, by myself and Andrew Westerkamp. Smoking is by far the most popular and most common method of ingestion for cannabis sativa. In a recent social media poll done at the end of May 2021, over 76% of both medical and recreational users say that they prefer smoking. It's well known that smoking and edibles actually cause very specific therapeutic profiles. There are three main differences between smoking and edibles that cause this. The first is absorption. Smoke is absorbed in the lungs and goes straight to the brain, so it happens much faster. Edibles need to be digested and absorbed in the small intestine and can take anywhere between 45 minutes and 2 hours to kick in. The second difference is metabolism. The cannabinoids in edibles are metabolized by the liver before they reach the brain, and this contributes to some of the differences in effects. The third difference is the transformation of cannabinoids at high temperatures, and is the focus of this poster. Most methods of smoking cannabis sativa use temperatures higher than 400 degrees Fahrenheit. And at these high temperatures, the cannabinoids isomerize and transform. Some of these molecules might be completely inert or inactive, but others might show bioactivity that we haven't yet investigated. It's possible that the transformation of phytocannabinoids by heat contribute to the differences in effects between smoking and edibles. To simulate the smoking environment, we used a glass cylinder that was hooked up to an electronic heating source. The starting material was placed in the preheated cylinder and a small vacuum was attached to pull it through a selective filter. The filter was then washed with 100% ethanol, and the compounds were analyzed by HPLC, LCMS, and NMR. We verified the purity of our CBD isolate by NMR spectroscopy and ensured that we could use it to create a standard curve and quantify CBD. All HPLC separations were run on a reverse phase gradient using a C18 column. In these simulated smoking experiments, we saw that using CBD isolate, hemp distillate, and hemp flower all resulted in significant transformation of cannabinoids present in the resulting smoke. A scaled up and concentrated sample that was performed at a lower temperature was sent for MSMS analysis, and 78 known cannabinoids were identified. This same sample was separated on flash chromatography, and one of the isolated compounds was then analyzed by LCMS and NMR. It was identified as cannabidiol, or CBND. This is interesting because CBND is likely present in hemp smoke, but is not contained in traditionally extracted hemp products. Most edible products are created from extractions that focus on preserving the primary phytocannabinoids like THC or CBD. A better understanding of the total cannabinoid formulation of cannabis smoke will help us to develop better therapeutic options for users.